Welcome back. And we're going to do an example with a disaccharide. And I threw another little monkey into the work, a wrench into the works here. I put an L sugar. Oh my. What are we going to do? We don't have pictures of the L sugars, do we? All you need to know about L sugars is they are the enantiomers of the D sugars with the same name. So if you know how to draw D-glucose, which you do because you have the handout available to you, glucose. So you find D-glucose, and right beside it, you're going to draw L-glucose, and you're going to follow all the steps that we just learned. Piece of cake, right? So over here, we had all of our sugars. D-glucose is one of them. It's down here, and it goes right, right, left, right. Just remember that. Right, right, left, right. Right, right, left, right. Aldehyde on top. Right. Oh, I made a peroxide. Left. Right. And I know I made a mistake because I just drew glucose by mistake. That one I've got memorized. I didn't listen to myself. D-glucose. In review. Right, right, left, right. I only had one on the right, didn't I? Right, right, left, right. Right, right, left, right. So the mirror image of that sugar is L-glucose. And once again, on the ends, I don't care how you draw the OH there or the aldehyde up here. If you want to make it point towards the mirror, it's fine. They are not stereocenters. It doesn't matter which way these point, but it really matters which way these point. The enantiomer of this R stereocenter is this S stereocenter. Similarly there. This one's to the right. And the one that makes this an L sugar is right here. Look, what side is that on? The left. L sugars have that stereocenter on the left side. They're not natural, but they are found in nature. That makes no sense at all, does it? Well, this particular one, I don't think you're going to find too many examples in nature. But when nature does require an L sugar, what it does is it goes to its repository of D sugars and does chemical conversions to make a D sugar into an L sugar. So next time you're studying your blood types, where there are L sugars in everybody's blood types, remember that L sugar came from a D sugar that your body manipulated into being an L sugar. There's L-glucose, and we're going to draw a pyrano side of it. So is that an acetal or a hemiacetal? It's an acetal, and that means the anomeric O on carbon 1. How do I know carbon 1 is the anomeric carbon? It's the one with 2 bonds to O. It'll have a bond to a carbon instead of an OH, it'll be an OC. And the OC will be carbon 4 of this other sugar. That's what that means. Carbon 1 of the sugar to the left is linked to carbon 4 of the sugar to the right. And it's a disaccharide. And let's get busy. We'll do the first half here. You're going to practice, 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 and get to this point right here. It's a pyrano side. So when you're all set, it's going to look like this. And this will be up left, as will this. down right. And I think we're still too early in the game to jump to this one. So before you got there, you were here. Up left, down right, up left, CH2OH in the loop. This is the stereo center that you need to rotate, because that's the oxygen I need. So I make sure I put the H here. This time the O must rotate into position this way, which is counterclockwise. No, fully clockwise. But then again, I told you, don't memorize which direction to rotate. Find the O that's necessary, rotate it to the position where it needs to be. That was this direction. Oh, that is clockwise. Now I know. But if you're memorizing things like clockwise and counterclockwise, you'll be, you won't be helping yourself. That's all. And this is the O here. And the H is all the way up here. CH2OH is down here. And if this is to be an alpha sugar, this is where your biology teacher would be losing points in this test. What is trans to this CH2OH that is down? It's up. Yes. We have an alpha sugar with the anomeric O up, which goes directly against what some of your biology teachers taught you. But it's correct. And it's not an O bonded to H. It's an O bonded to carbon number 5 of this next, no, carbon number 4 of this next sugar. Carbon 4 of the next sugar. Let's figure out what the next sugar looks like before we connect them. So right now we've got a lot of points just for drawing that. I got to find arabinose. D-arabinose. We'll do that one over here. Have everything meet in the middle. Arabinose. That is an aldopentose, if my memory serves correctly. Aldopentose. Aldehydes, arabinose. Left, right, right. Left, right, right. Left, right, right. And the icon will be here. And that is the CH2OH on carbon 5 right there. Don't have to add to the ring. OH's left is up, uplefting, down right, down right. Find the anomeric O. And why is it this one? I need ring size to be 5. That's what furanose means. Furanose means 5. And this would be 5, counting carbonyl number 1. 1, 2, 3, 4, 5. Putting the H on. Going straight to my ring. I might want to consider where I draw this molecule. Now that I know carbon 1, 2, 3. I noticed there's a mistake, yes. I ignored the fact that on carbon 5 it says there's deoxy. Oh, that's okay. That's my D-arabinose. My next drawing will have this O disappear. That's what deoxy means. The O is gone. It'll be a CH3. And carbon 4, this O, I'm going to redraw it the right color. That O is already drawn on my other sugar. It's the one that made this ring. Sorry, connected with this ring from here. It says carbon 4's alcohol of this sugar connected to carbon 1 position of the previous sugar. So I'm going to go here and copy all I see here with the ring size and everything I need and rotations. Oh my God, there's going to be so much going on. Hope I don't lose anybody. Going to do some rotation. And I got a problem. I'm really sad. I confess. I'm confessing. Confession's good for the soul. I made this problem up right before we did it. And you can't, that O is the one I need to use to close the ring. And it can't also be the O that's here. Yeah, it's really sad. It's okay. Just edit the question. I need my eraser. It won't let me erase that. Life's complicated sometimes. That's why we have whiteout. I can't use that. I'm just changing the question. Make it a 3. That's a big 3. That's a pretty big mistake. So this little blue O here, I like the highlighter because I do need that O to make my ring. That's all I can use that O for. There's the O, H. Here's my highlighter. But the name says carbon 3 of this sugar is the one that's going to link with this ring here. There's my blue O. That's the blue O. So I'm going to copy everything here. That O is this O. It's already drawn. Yep, this is going to take practice. Goes up to 3 to 2. Has an OH straight up. Has a carbon. It's the anomeric carbon. It's going to connect to the O, the highlighted O. Yellow highlighter. And that's going to be this O here, connected to carbon 4, which has a down H, and an up CH3. Notice I said CH3. I'll even write CH3. And this is down here. It's not the best looking pentagon. Yeah. 5-deoxy, right? 5-deoxy, that is missing its oxygen. The only thing we have to do now is decide which way the anomeric OH points on this thing. And how do you know it's an anomeric OH? What's the end? OSE. OSE means hemiacetal. It's going to have an OH. It's beta, which means it's cis to the CH2OH, which is now a CH3. Has to be up. Nah, don't do it in blue. There's your beta. Cis to each other. This here is a 6-point problem. Let's just review all the parts. We found D glucose because we don't have a handout with L sugars on it. We drew its mirror image because that's L-glucose. We figured out which O to use. It was this O. Rotate it into position. Close the ring. Here, this sugar has to be alpha. The one on the left has to be alpha, which means the anomeric O is trans to the CH2OH here. That's alpha. Carbon number 1 of this sugar, there's 1, is hooked up to carbon 3 of the next sugar. There's 3. You want the numbers? 1, 2, 3. And carbon number 1, 2, 3, 4, 5, 6. Might as well continue all the numbers since I'm on this path. There you go. 1, 3. And this sugar has to be beta because the name says so. And that would be the cis to the C. In our next example, we're going to have to do an alpha or beta where there's no CH2OH over here. And let's do that. Oh, I went backwards. Draw D-fructopyranose ide beta 2 to 1 with 2 amino yeah, beta 2 to just spotted something. Don't have to do a whole bunch of apologizing later here. To beta 1. Yeah, there's 2 Greek letters in the middle with 2 amino D-glucofuranoside. Wow. There's a lot there, isn't there? We're going to have to find fructose and glucose. Fructose is a ketose. Glucose. If you're going to memorize one of them, I know you don't have to because you have the handout as your security blanket. But glucose is by far the most prevalent sugar on this planet. Next time you're in a forest, look at those magnificent trees. What holds them all together and makes them stand strong? Cellulose. What's cellulose made of? Glucose, a polymer of condensed glucoses. There are millions and millions of tons of glucose in every forest. So glucose, it's right here. And as you take more and more biochemistry courses, you'll know that D-glucose is interchangeable with D-fructose if you do tautomerization on the second carbon. That will be part of Wednesday's lecture. So carbons 3, 4, 5, and 6 are identical in both species. But anyway, these are on the handout. You don't have to do any of this for me. There's your D-fructose. And notice carbon number 2 of fructose is the carbonyl. Carbon 1 of the glucose is the carbonyl. And I think this is going to be our first example where the two anomeric carbons are linked up together. And I'm going to let you do all the steps on your own. And you should get to this right here when you do the ring for fructose. And it's a fructopyranoside. I should do that last step to point out something. You're going to have your icon. And we're going to go carbonyl, and then you have to fill in the CH2OH that's missing. That's carbon 1. And then all the OHs, up left for carbon 3, down right for the next 2. And then CH2OH is already in position to make a hexagon. Look at that. We haven't had that yet. This O is already in position to make a hexagon. That's the O I need. How do you know? Well, the name says pyranoside. I need a hexagon. So that saves us a rotation in this example. And I don't know about the blue CH2OH, so don't draw it. The purple O is in position, and it has made its bond. And the other O's are all in position, not changing. And the name says beta. Beta. Beta means the the new O that you're going to draw on the anomeric position has to be cis to the CH2OH over. There is no CH2OH over here. We use the CH2 to make the ring close. Let's go back to page 1 and see if we have an alternate definition if the CH2OH is missing. If not, I'll give you a nice alternate definition. It's not page 1, it was page 3. If there is no CH2OH group, then the anomeric hydroxyl will be down for D sugars. I gotta edit this. This handout's a little on the old side. So there's your biology definition for D sugars, which covers like 99.9% of all the sugars. Up for L. L is the opposite. Similarly, if there is no CH2OH group, then the anomeric hydroxyl will be up for D sugars. Down for L. Okay, and that covers it. And go to our last page here. All right, so we have a D sugar, and the anomeric, the CH2OH is not here. So we got to use our fallback definition for D sugars where beta is up, and there's an oxygen on it. I'm drawing it way up, and blue was an unfortunate choice of colors. And the CH2OH, the blue one here, has to be on carbon 2 here, because that's carbon number 1. And if you drew this O up, based on the alternate definition, That has to be down. And that's going to be connected to carbon number 1 of glucose. That's what it says. This O is connected to carbon 1 of glucose. Glucose is in a furanoside. Wow. So, and glucose is beta. There's a furanoside. Beta. That means that bond's going to be up from a furanoside. There's a terrible furanoside. Up. We just have to get that furanoside. Because up here is going to be side. There's going to be stuff there. I have no idea what that even looks like. There's a lot going on in this question. D-glucose, all the steps. You've got your uplifting on carbon 2, down writing. Oh, sorry. I apologize. That's not left. Last time I checked, that's the right. Down writing on 2. Uplifting on 3. Down writing on 4 and 5. And then we need the CH2OH to be in the loop. CH2OH in the loop. Now we have to pick the right O to make a furanose. That's 5. Not that one. 1, start at the carbonyl. Then you count to 5. One of the O's has to be the 5th. 1, 2, 3, 4, 5. It's that one. Highlighter. That one. Which means we've got to rotate. And this whole deal gets rotated. It's a group. And I just want to make sure we rotate everything the right way. The O rotates up to where the blue circle is. The blue circle rotates to where the H is. And the H rotates down to where the OH is. There it is. We didn't touch those other stereocenters. I know I couldn't draw it straight down, but it's definitely down, right? This O, it's down. It's not up here. It's down there. And this one's up here. And then we get to a point where we don't know how to draw this stereocenter here over here. And then it's just time to realize sometimes it just comes down to making sure if it was R here, which it is. One, 2, 3, 4 is not S, therefore it's R. Remember, this is a wedge. That bond there is a wedge, which means 1, 2, 3 is incorrect. This is not S, therefore it's R. I need it to be R here. And the only way to do that is to have O, CH2OH, H. Let me verify that. And I think I got it wrong. Sad. It goes 1. I did. I got it. I say I had a 50-50 chance. I guessed. And then I realized I was wrong. And I needed it to still be S because it was, sorry, R. It was R here. I need it to be R here. So if I go 1, 2, 3, it's not S, therefore it's R, and that's correct. And guys, it's not the end of the world if you get that stereocenter wrong. It's probably a half point. And I totally ignored the fact that I had 2 amino in the name. I'm glad you guys are so patient with me. What does 2 amino mean? It means in the same position where you used to have an OH is an amino group instead. And I'll put it in green. It's NH2 on carbon 2. Pen's off. My computer's telling me it's time to take a break. So instead of an OH, carbon 2 has an NH2. And this 2-amino. That means it was an NH2 here as well. And we'll tidy it up for our final answer here. Aminoglucose is very common. It's found in nature. It's found in your tendons. So it's good to know. Do we have everything we need for this lovely 6-point problem? We have why was this beta here? Well, for a D sugar, beta is up. For other sugars, where there's a CH2OH there, beta is cis to the CH2OH. This is one of those other sugars. It's beta. It better be cis to the CH2OH up here. It's actually the whole carbon group, but hey, the carbon's definitely up, and beta means cis. And that one's also, they're beta and beta, because the name says they had to be. We had an amino sugar, and this is a nice stopping point. We're going to finish by doing a problem where we're given a drawing and have to name it. And then we're going to do the original problem that was right there on the first screen from the very beginning and see if we can handle naming that one too. So I'll see you very soon.